Hello, we are from Group 9 and today we'll be presenting the 2018 Florida International University Pedestrian Bridge Collapse. On March 15, 2018, the 174-foot-long main span suddenly collapsed onto the road below, killing 6 people and injuring 10. This tragedy drew national attention not just for design flaws, but also for serious lapses in engineering ethics, communication, and safety oversight.
For the discussion of topic, the construction of the FIU pedestrian bridge began on March 1, 2017. Almost a year later, on February 6, 2018, hairline cracks were observed on diagonal members 3 and 10 during post-tensioning. There are more serious cracks appear on February 24th, particularly on vertical member 1 and at the critical joint between members 11 and 12. On March 10, the 174-foot-long main span was installed over the southwest edge street using self-propelled modular transporter, and traffic resumed shortly afterwards. Between March 11 and March 14, workers noticed that there is worsening cracks near member 11. Despite these signs, a safety meeting on March 15 at 9 a.m. concluded that the cracks were not a safety concern and retentioning would continue while the road remained open. Tragically, at 1:46 p.m. the same day, the bridge collapsed, crushing 8 vehicles and resulting in 6 deaths and 10 injuries.
The FIU pedestrian bridge collapse was the result of serious technical and engineering issues and clear violation of safety law. The most critical issue was the underestimation of shear and interface demands at Node 1112. The design team miscalculated the joint's capacity and provided insufficient reinforcement, causing the knot to become overstressed even under dead load. This violated the OSHA General Duty Clause Section 5A1, which requires employers to protect against recognized structural hazard. Reinforcement detailing was also inadequate. Diagonal member 11 lack of proper anchorage and confinement, and simulations later showed that retentioning forces exceeded the joint shear capacity. This violated the OSHA Regulation 29 CFR 1926.754A, which mandates that structures must safely support all loads during and after construction. In addition, the engineers misinterpreted the large shear cracks, some nearly 0.75 inches wide, and proceeded with retentioning instead of halting work. This failure to act on visible distress again violated the Section 5A1. Finally, the bridge is lack of redundancy. With no secondary path, one member's failure led to full collapse, an outcome that both OSHA regulation and modern engineering codes are specifically designed to prevent.
Next, we will go through the key ethical reasons behind the FIU bridge collapse, using the National Society of Professional Engineers Code of Ethics as a framework. First, public safety was ignored. The cracks were reported but dismissed, and the road remained open, violating Canon 1. Second, there was a miscommunication. FIGG's engineer downplayed the cracks, misleading others, which violates Canons 3 and 4. Third, there was a diffusion responsibility. Multiple agencies had authority to stop work, but none acted, again violating Canon 1. Next, poor design judgment. Loads were underestimated and the bridge lacked redundancy, breaching Canons 1 and 3. Lastly, there was a conflict of interest in the peer review, which was neither independent nor qualified, violating Canon 5. Overall, this case shows how ethical failures can be just as catastrophic as technical ones.
To prevent tragedies like the Florida International University bridge collapse, several key improvements must be made. First, strengthen the technical and the design practices. Future structures must include accurate interface, shear calculations, and design redundancy. This aligns with the NTSB recommendations. Peer reviews must be conducted by qualified independent engineers as required under the Florida Administrative Code Rule 1475, and any structural changes should be approved by the original engineer of the code. Secondly, enforce construction safety. Visible cracks must trigger immediate inspections and road closure. OSHR regulations require that all personnel be informed of site hazards, and real-time structural health monitoring should be used to detect early signs of failure. Thirdly, uphold ethical responsibility. Only licensed engineers should make safety-related decisions. According to the NSP Code of Ethics, Canon 1, engineers must hold public safety as their highest priority, and organizations must support a transparent, safety-first culture. Lastly, regulatory oversight must be stronger. Peer reviews should not be a routine paperwork but a thorough evaluation as emphasized in the Florida Administrative Code Rule 61G15-18.011 to ensure design reliability and public protection.
In conclusion, the FIU bridge collapse was a preventable tragedy caused by design flaws, ignored warning signs, and failures in professional judgment. It violated the NSPE Code of Ethics, OSHA safety standards, and Florida's engineering regulations. Stronger engineering oversight, safety culture, and ethical responsibilities are vital to avoid future tragedies. That's all from us. Thank you.